So whenever I say multiple processor, it's a most complex taxonomy that I have in the interaction testing. The difficulty arises from the combined Petri net grows exponentially. The dial inputs or the dial events what I have, so that is causing the transitions. Hello everyone, I welcome all of you to the next session on the interaction testing. My dear students, in this session I will be discussing the next part of the taxonomy which we were discussing in the last class. Alright, so what exactly that we have discussed in the previous sessions, just recollect before we start the session. Hope you have watched the session and don't forget to click on the like button if you have watched it. So what is that I have in this session? Guys, I will be discussing about the dynamic interaction in a multiple processor. So this is going to be the agenda for the day. We have been discussing this taxonomy from the previous session. So what exactly that we had in the session 1, we had static interaction in a single processor and static interaction in a multiple processor, and also we have discussed dynamic interaction in a single processor. It's time for all of us to understand the problem and the complexity that we have with respect to the dynamic interaction with a multiple processor. So fine, let's check what exactly that I have. Whenever I say dynamic interaction with a multiple processor, so please understand that I will be dealing with the multiple processor. So whenever I say multiple processor, it's a most complex taxonomy that I have in the interaction testing. So that's what you need to remember. So why do you call that as a most complex taxonomy? I have a point for all of you, because threats and events can execute simultaneously. That's a major thing that I have here. So please remember. So I will be executing the threats as well as the events simultaneously. So that leads to a complex scenario. Right, that is the most important point that you need to remember with respect to this topic. Moving forward to the next point, dynamic interaction on multiple processor needs an expensive communication media is what I will be able to tell you. So what exactly that I need to convey this? I need the expensive communication like finite state machine or some Petri nets. So why? Because the system is very complex, because multiple processor will be executing dynamically. So that is what you need to understand here. Moving forward to the next point that I have. The problem here is threats and events occurs in parallelly. That's what we have discussed in the previous slide. So that's a major thing that we have. Moving forward to the next one, we have concurrent behavior. Whenever I say multiple processor, so obviously I have to have the concurrent behavior, concurrent in the sense parallelly it will be executing. That's the most important thing that you need to remember. When I execute parallelly, obviously I will be coming across with the different situations like mutual exclusion, and also I should share my resource. How do we handle all these things, and how exactly the interaction will happen when we are executing the things parallelly? That's what we are trying to understand here. Alright, so concurrent behavior with a collection of communicating sequence processor, and also I have no non-deterministic behavior. What exactly this non-deterministic behavior? When it comes to the non-deterministic behavior, I will not be able to predict what exactly that it's going to happen. So I will be speaking about this in detail in my next session. So please make a note on this. Alright, so this is the things that I have to keep it in my mind with respect to the dynamic interaction in a multiple processor. Let's take an example to understand this concept. So that's going to be the windshield wiper problem. So what exactly that we will be able to understand with respect to the windshield wiper problem. So guys, let's take a look. I want all of you to please be with me until I explain this completely to all of you. So guys, observe carefully. When I take this example, I will have three things. What are the first thing that I have? So please understand, I will have to consider the condition of the lever. So the first thing that I have to consider the condition of the lever. So windshield wiper problem in the sense you have the car, right? So in the car, you will have the wiper, right, which cleans the glass. So that's what I'm speaking about. Okay. So fine. The first thing that I have to consider the liver condition, not your body liver condition. All right. So fine. The next one that I have is dial. All right. So you use the dial the switch or the device to set the condition, right? So in the wiper. So that's what I will call it as a dial. And the next one that I have is wiper. This is what you need to remember here. So fine. What exactly that I need to understand with this example? So listen to me carefully now. So guys, please observe this example. Let me clear the screen for all of you. What exactly that I have here? So I have the initial table. When the liver condition is off, okay, please observe, dial, it is not applicable and wiper speed is 0. So fine, I understood that. When the liver condition is in the initial, okay, that I will call it as an interval or whatever you want, you can consider. So I have dial in the first position. Dial is in the first position and my wiper speed is 4 per minute. Okay, what is the speed of the wiper? This 4 per minute. That's what you need to understand. Suppose if I put that to the second position, so what happens? What will be my wiper speed? My wiper speed will be 6 per minute. When it moves to the third position, my wiper speed will become 12 per minute. So that's what you need to understand. So this is one case. How many places I have? So I have 3 places, 3 different places. Observe this. Moving forward to the next category. So I have one more category, that is low. When I set it to low, automatically the speed, the dial is not applicable here because I have set it to the low. Now my wiper speed will be 30 per minute. And when I put it to the high, my wiper speed will be 60 per minute is what you need to observe with this table. Right? So one more important point that you need to observe here, when I put it to the low and high, so guys, dial is not applicable. That's what you need to remember. Right? I will be speaking about these 3 positions little later. So please keep that in mind. Right? Moving forward to the next thing that I have. So guys, I have a Petri-net diagram with me to explain the same concept here with these 2 tables. So I will be showing you all with the port input events and port output events, how exactly this wiper is behaving, the system is behaving. Let's try to understand. So guys, first in the liver is in the off state and in the initial state and in the low state, high state, right? So fine, listen to me carefully now. So what exactly happens here? So guys, IE, whatever I have here, I will call it as a input event, okay? So here I have input event 1. Whenever I give input event 1, what happens here? That's what we have mentioned here. So liver from off to initial stage is what we are trying to move. That's the transition is happening. So when it moves to the next one, so please observe. So what is happening here? Input event 2. What is the next input event? So please observe input event 2. When it comes to the input event 2, so from the initial it is moving to the low. So that is what we have mentioned here. Along with that, in the same way, at the same state, so please observe, I have one more thing. So what is the next thing that I have? So output event 5. So what is that I have? Output event 5. So output event 5, you will get it here. It means to say that your wiper speed will be 30 per minute. So please observe here. Wiper speed will be 30 per minute. So why it is 30 per minute? So please observe, when it moves to the initial to low, so guys, what will be your wiper speed? Your wiper speed should be 30. That's what you need to remember. Let me erase the board, right? So now you're able to see this, right? So please observe. So fine, we understood. Then what happens next? So please observe input event 3. What happens when it comes to the input event 3? So please observe, lever moves from low to high. When it goes to the low to high, so I will have output event 6. So what will be my output? So output event 6, 60 per minute, 60 rotations per minute. That's what you need to remember here. And then again, when it goes to high to low, I will call that as a input event 4. Input event 4, again, I will have 30 WPM. So that's what you need to observe. And again, it goes for IE5, input event 5. So low to I. So what happens here? So please observe. So guys, input event 5, lever moves from low to initial. That's what you need to observe here. But they have asked the question mark. So what is the output event? That's what you need to understand. When it moves to the low to initial, it is asking what should be the wiper speed, because guys, to which position it is going, whether it is going for a 3, 2 or 1. So that's a question that you need to answer here. So this is the problem that we have when we are interacting with the system. And then when I move from initial state to off state, so please understand my output event will be what? So my output event will be, guys, OE1, that is 0 rotations per minute. That's what you need to understand. So this is our best example that we are trying to understand. All right, so multiple things are happening. Okay, multiple things are happening and a lot of communications are happening here dynamically. So that's what you need to remember. Let me explain this in detail. Before that, you need to understand the difficulty arises from the combined Petri net grows exponentially. What happens when the system grows complexly? So the difficulty arises. A lot of things are communicating parallelly. So there the problem comes for the interaction is what you need to remember. And maybe the difficult rationalize initial marking. That's what you need to remember. And the last point that we need to remember is have mutual exclusion contraries. Mutual exclusion in the sense what? If I give, only then you will give. So that's what we call it as a mutual exclusion. All right. So there comes the opposition. Okay, there comes the opposition. So that is one of the problem that I have with respect to the windshield problem. So that's most important problem that I need to address is what you need to remember here. All right. So guys, so the next important point that I need to remember with respect to the EDPN, please remember the 3 dial positions. I told you in the beginning to remember the 3 dial positions, 1, 2, 3 are the 3 data places. That's what you need to remember. Now we are coming to the point with respect to the example. 3 dial positions, what I had, 1, 2, 3. I will call that as a data place. Observe here, the dial events are the input that causes the transactions. What exactly that I have? The dial inputs or the dial events, what I have. So that is causing the transitions is what you need to remember. And the last point that I have here is dial EDPN has no output port event. So that's the most important point that you need to remember. When I have the dial, dial will not have any output port is what you need to remember at this point. So moving forward to the next points. Guys, I have some of the points which I have listed here. Let me discuss this problem or let me discuss this points with respect to the diagrams what I have here. The complete EDPN, the windshield problem, they have described with the Petri net diagrams here. So beautifully they have represented. So if you want to understand this, so the entire diagram they have represented with the help of this table. So in this table you need to observe 3 important points. The first point that I have here is S1 to S3. This is what I will call it as a sequence. I also call this as a transitions is what you need to remember. So fine. The second one that I have, that is D1 to D7, that I will call it as a device. All right. That speaks about the dial. And I have the ports. So P1 to P10. So please remember this. So this is the 3 important things that you need to remember with respect to the entire system. So you all know that. So the arrow mark, if it is coming like this, so you should read that as an input. And if the arrow mark is, like this, so please observe the arrow mark is like this. Okay, treat this as an output. All right. So let's understand this. Okay, with this table. This table will give you the complete idea of this Petri net diagram. What exactly that I have here? S1, whatever I have here, please observe S1, S2, S3. I'm speaking about the S now. So S3, and I have S4, S5, S6, and I have S7. Observe here S7, S8, S9, S10, and S11. So observe it is going like this. Or the sequence is going like this. All right, then finally it comes here. What exactly is happening here? Observe and understand the sequence. It is coming like this. All right, so this is the way that it goes and comes back to the S11. Observe transition off to initial stage and transition initial to low and transition low to high, transition high to low, low to initial, initial to off, 1 to 2, 2 to 3, 3 to 2, 2 to 1, and then provides 6 strokes per minute if it is S11. So that's what you need to remember, and provides 12 strokes per minute, S13, 20 strokes per minute. That's what you need to observe, S12, S13. So guys, this is the transition that they are speaking. So in each transition, okay, in each sequence, they are speaking about the transition from one state to another state. That is what they are speaking here. So this, whatever I'm writing lines, this is the transition is what you need to understand in this diagram. From one state to another state, they are trying to move. So fine, we understood that. What is the next thing that we need to remember? So please understand D1. What exactly that I have here? This is the D1, D2, D3, and I have D5, D6. So please remember this D. What exactly that I have with respect to this D's? Listen to me carefully. Lever at off dial position is what I'm speaking. Lever at initial state, and lever at low, lever at high, dial at 1, dial at 2, dial at 3. So this is the dial position is what I'm speaking. Even sometimes dial is also treated as an input is what you need to remember to this system. So fine, we understood the sequence which is moving from one state to another state. So you are understanding the state transition with respect to S. With respect to D, D is the position of the dial. So that's what you need to remember. Alright, so fine. Moving forward to the next one that I have, ports. What happens with the ports? P1. P1 in the sense what? Move, lever up one position. Lever up one position. So that's what you need to remember. P1 in the sense, lever up one position. So here I'm giving the input. So lever up one position. I'm upping the lever for one position. That's what you need to remember. When it comes to P2, so move the lever down one position. Move the lever down one position. And P3, move the dial up one position. So this is the port input places is what you need to remember. Let me just read it for all of you. P4 in the sense what? Move the dial down one position. P6 in the sense provide 6 strokes per minute. P7 in the sense 12 stroke. P8 in the sense 20 stroke. P9 in the sense 30 stroke. P10 in the sense 60 strokes per minute. So this is the input that you are giving. So please observe. Sir, why do you say this as an input? So please understand, P1 is input. So P2 is an input. P5 is also input. That's what you need to remember. Guys, can I call this as an input? You should treat this P5 as the output. What exactly that I have? Provide 6 strokes per minute. So treat this as the output. So observe wherever I have in the diagram. Okay. So this is what I will treat it as an output. So this is what I will treat it as an output. If I get this 3 things as an input, so I will be treating this P5 as an output. So observe here, I'm getting the output. So this is what I will call this 3 things. I will call it as a input. So that's what you need to understand. So here, what is the input? P1 is the input, and then P9 is the output. So P2 is the input here. That's what you need to remember. So guys, and then here P1 is input, P2 is input, and P10 and P9 is output. That's what you need to observe here. And then I have P4 and P3 is the input here. And then here P3 and P4 is the input. That's what you need to remember. And I have P8, P7, P6 is the output. This is the system that we need to remember. Why are we discussing? At the end, there is a conclusion. Sir, software testing gali idinella yake helta idira sir? You need to remember one thing. My dear students, multiple things are happening at the same time by coordinating among themselves. The position of the dial matters a lot for the speed of the wiper and the condition of the wiper. So all the 3 things should coordinate dynamically. So the interaction should happen with multiple things. Each thing should be monitored by one thread. Say for example, dial should be monitored by one thread, and the wiper blade should be monitored by one thread, and the speed should be monitored by one thread. So multiple things are coordinated simultaneously. That's why we call it as a dynamic interaction with a multiple processor. So hope you understood this diagram. So this was a most important thing that you need to remember. This is what they have given with a marking this simple scenario. Guys, Please observe, this is the marks that they have given, and this is the dial positions. Dial 1, if it is present, they have marked it as a 1. So for dial 1 to dial 7, and then P1, okay, observe here, P1, if it is present for this scenario, they have marked it as 1, and if that is the case, what is the description is what they have mentioned it here carefully. So what we have discussed in the previous slide, that they have discussed in detail even in this table. You don't have to read the entire theory, so you just have to understand this table in the diagram what I have discussed in the previous slide. So by saying this, I have come to an end of this session, which completes the taxonomy is what you have in the interaction testing. So hope you will be waiting for me till the next session. Until then, take care. Bye bye.